Assalamu alaikum, students. Today, as you know, I am going to revise with you the revision sheet for past paper questions. Basically, the aim is to revise for all the concepts which are contained in the study list. And inshallah, after this revision, you guys will have a thorough, a revision or concept command on all the topics contained in the study list. So in front of you right now, I am showing you the answers, and through the answers, inshallah, I will explain you if anything will be required and you would need more explanation. Okay, so let's start with the very first question. As you know that the first testing concept is circles. So question number one, he has given you a circle, right? And in this circle, I can see isosceles triangle. Why isosceles triangle? Because we have radius given. The guy has given you the radius. So when I can complete the triangle, it is an isosceles triangle. And we remember the famous the property of isosceles triangle. If two sides are equal, their opposite angles are also equal. So this property is very famous for isosceles triangle. So I'm gonna use that. Another important property, if you know this angle, you can find the third angle. We remember that the sum of the three angles in the triangle is equals to 180. Clear? Also, I can see in this circle question, we have the angle at the center made by the arc, and the same arc is making an angle at the circumference. So is there any connection between the central angle and the angle at the circumference? The answer is yes. This angle is always double and this angle is always half. Let me explain you. If you have a circle and the center is given, and I'm going to use a minor arc AB. So the endpoints of the minor arc are joined at the center. And now I'm going to join the same ending points of the arc, the minor arc. This is the minor arc. If I join them anywhere on the circumference, so if this angle is 2x, at the back, it is always x. So as I said, this is doubled and this is always half. Clear? If I pick this point, so this is also the same, double, and this is half. If I'm picking this point, this is double and this is half. And the name of this property is angle at the center is double the angle at the circumference. Now, another important property I can see if I'm using this arc is making an angle here, and also it is making an angle here. And the name of this property is called angle in the same segment. I will again repeat it. If you have a circle and you have an arc, if your arc is making angle anywhere on the circumference, these angles are always the same. And this is called angle in the same segment property. In the class, we discussed it in detail. Do we have any other property used here? I think it's better now to go through with the questions one by one. The first question he asks you, find the angle POS. Where is POS? This is P, this is O, and this is S. The guy is asking you angle POS. So this is the angle required. Now, since he has provided you this angle 45, and we remember that this is isosceles triangle, the opposite angles are equal, then I'm say that this is also 45. So if this is 45, this is 45, I can easily find this angle. How? 180 minus 42 plus 42 will give you 96. So the third angle can be easily found by using the isosceles triangle property and angle sum of a triangle, which is equals to 180. So this is done. This is done. Next is angle PRS. Where is P? This is P, this is R, and this is S. So he's asking you what is angle PRS. As I have told you already that the guy is asking you PRS, yani this angle is required. So can I connect it with the central angle, which I have already found at 96. So this is always doubled and this is half. So half of the 96 is 48. Name of this property is what? The name of this property is angle at center is twice the angle at circumference, which is written over here. Next. So this is done. Angle SPQ. SPQ. So where is S? This is S. This is P and this is Q. So he's asking you this angle. This total angle is required by him. How can I get it? I can use the concept of cyclic quadrilateral. Can you check? This is a cyclic quadrilateral. How did I teach you cyclic quadrilateral concepts? So if I have a circle, if four corners of the cyclic quadrilateral are on the circumference, then this quadrilateral is called cyclic quadrilateral. And what special cyclic quadrilateral has? The opposite angles are supplementary. So the opposite to this angle is this. So if this angle is x, then this opposite angle is 180 minus x. The opposite to this angle is this. If this is y, then this opposite angle will be 180 minus y. In other words, the geometric property, which is called supplementary angles, the sum of the two angles, if it is equals to 180, we call them supplementary angles. So opposite angles in cyclic quadrilateral are supplementary. If this is 60 degrees, obviously that will be 120 degree, because I know 120 plus 60 is 180. So that is special only with cyclic quadrilateral. But if I have any quadrilateral in which the corners or the vertices are not passing through the circumference, no, they are not supplementary. Okay, so be careful about that. Let's move to our question. In the question, you remember, I have just found 48, and the guy already provided you 35, this angle, so I can add them up. If you can add them up, you will find all these angles, 35 plus 48. Then using cyclic quadrilateral property, you write here 180 minus 35 plus 48. The answer comes to you 97. So this total angle is 97. And how did I get it? Because I found that this angle is in total 35 plus 48. When I added them up, okay, then I subtracted this angle from 180 to get 97, the opposite angle in a cyclic quadrilateral. So this is also done. Last question, PSQ. PSQ, let me erase everything. PSQ. Where is P? This is P, this is S, and this is Q. So he is interested only in this angle. You remember I have already found the bigger angle, which is 42. So how can I reach to this angle? Now, as you remember that this is the arc, which is subtending angle at the circumference, this one, and also it is subtending angle here. So angle in the same segment property says that if this is 45, that is also 45. Interesting thing is this, examiner has made me to focus on this triangle. I have recently found that this angle is 97. So 97 is known to me, 48 is known to me. I can easily add them up and subtract them from 180. That will give me this answer, which is I think 35. 180 minus 97 plus 48, that will give me 35. So students, you need to understand, like in this particular question, he's asking you 4 parts and 4 or 5 properties which we took in circles. Again, I will repeat. In the first part, he has made use of the concept of isosceles triangle, in which opposite angles are always equal. And with the help of that, I used these two angles and to find the third angle. As we know, the sum of 3 angles in a triangle is 180. After that, I used the central angle property. The center is always double, and the angle at the circumference is always half. So this was 96 and I got 48. Then after that, he asked you the to use the property of cyclic quadrilateral because all the four corners were on the circumference. So I added 35 and 48 and subtracted from 180 to get this full angle, which was 97. Then after that, in the last part, boys, he was asking you to concentrate on this triangle in which I wrote this 48 by using the concept of angle in the same segment because he was using this arc and it was making angle on the circumference, same here and same here, 48, 48. The moment I know this is 48 and through the cyclic quadrilateral, I found 97. If in the triangle, if in the triangle, you know, this is 48 and this is 97, you can easily find this angle by adding these two and then subtract them from 180. So I hope, guys, this healthy discussion on one single question will help you to recall all the properties which we discussed in the class, inshallah. Now, the time has come to focus at question number 2. So in question number 2, before I move on and read what the questions and the parts he has made it over here, let's try to see the diagram and try to figure out what kind of questions the examiner may ask to you. Number one, guys, I can see clearly there is a diameter. Oh, wow, because any line which is joining the endpoints of the, the circle or maybe on the circumference, but that line is passing through the center, that line, this is called diameter. Now, if the diameter is given, endpoints of the diameter are joined anywhere on the circumference, like here, he has joined it. Always we get a 90 degrees. Let me explain you. I have a circle and I have a diameter. It means this chord is passing through the center. Now, if I'm gonna join the endpoints anywhere on the circumference, so this angle is always 90 degrees. Suppose I'm picking this point, join, this is also 90 degrees. If I'm picking this point, join the end point of the diameter here, you get a 90 degree. If I'm picking this point, join here, you get a 90 degree. So this property is called right angle in a semicircle. Very famous property. Right angle in a semicircle. So I'm expecting that this is 90 degrees. So imagine, guys, if I know this is 90, this is 29, I can easily get this angle. Hoping you will get 61. Another important property, if I'm using this arc wise, so this is making 61 here, and that is also 61, the angle in the same segment property. I can also see there is a possibility of having a cyclic quadrilateral like this, and this. So if you know this angle is 61, then the opposite to 61, this is 190. So that's another property of cyclic quadrilateral I may use in this question. Third property, boys, if you have a circle and you have a tangent, so radius and the tangent, they are always making 90 degree with each other. So I can see that property is also seen here. I have radius, I have a tangent, and this is 90 degrees. He told me that this angle is 61. From 90 minus 61 will give you 29. So very easy. I can find this angle. Another important property, which is called alternate segment theorem. If you remember, if I have a circle and you have a tangent, this is the point of tangency where the tangent is touching the circle, and I am gonna make a chord here. So suppose this is the chord, AB chord, and this chord is making an angle with the tangent. Supposedly, if this angle is 60 degrees, then I can get the same angle if the endpoints of the chord are joined anywhere on the circumference. So this angle will also be 60 degree, and this property is called alternate segment theorem. Agreed? So I am also expecting alternate segment theorem property because I have a tangent here. So imagine this is the tangent and this is the chord, boys. Sorry, this chord I'm talking about, not UT, this chord. So what is this angle? This is 61. So did he join the R and T point anywhere? The answer is yes. They are joining it here and they are also joining it here. So this angle is also 61 and this is 61. And then from 61, he used the cyclic quadrilateral property and he wrote 190. So I have discussed all aspects which are contained in this question. Let me ask you guys the first question he is giving to you, RTH. RTH. This angle is required. So how did I reach to 29? I use the concept that radius is perpendicular to the tangent. So total is 90. From the 90, I subtracted 61 and that gives me 29. So easy peasy, we got this angle. It has 1 mark, no need to write the property, but for your convenience, you can write the property there. But if it has 2 marks, you have to show the working over there along with the property. RHT. RHT. Now imagine I told you that this is a diameter and this angle is found by you 29, and this is 90 degrees, because if the endpoints of the diameter are joined anywhere on the circumference, you get a 90 degrees. So 29 is known to me, 90 is known to me, so I can find the third angle by using angle sum of triangle. So that will give you 61. So this is not very difficult. We use the right angle in a semicircle property. So that gives me 61. Now he is asking you RST. RST. Angle in the same segment. As you remember that, if I am using this arc, and this arc is making an angle here, and also it is making angle on the circumference. So this is 61, and this is also 61. This is 61, and this is also 61. Angle in the same segment. Clear? So this is also done. Now let's come to RUT. RUT, where is R? This is R. This is U, and this is T. Wow. So now he is going to use cyclic quadrilateral property. Since I remember this is 61, the opposite angle is 119, which is a supplement to 61. So I hope I have discussed each and everything in this particular question number 2. Now we move to question number 3, which is related to symmetry. He's asking you which type of a quadrilateral, because we remember there are many types of quadrilaterals we have studied. Okay, so let me erase this. Okay, and suppose if I'm drawing a rectangle, this is a quadrilateral. How many lines of symmetries it has? It has 2 lines of symmetries and 2 order of rotation, because if you rotate it about the center 360 degrees, in how many times it will repeat? So 2 times. So 2 order of rotation and 2 lines of symmetries. Square, it is a quadrilateral. It has 4 lines of symmetries and 4 order of rotation. Any regular polygon, same number of sides, same number of lines of symmetry, and same number of order of rotation. Kite, guys, is a special shape in which adjacent sides are always equal. Interesting thing is this is the only quadrilateral which has only one line of symmetry, and it has no order of rotation. Okay, it has no rotational symmetry, but order is 1, because if you rotate it 360 degree, in how many ways it will repeat? So in one rotation, it will repeat only 1 time when it comes back to its original position. So which shape he is talking about? A kite is a shape which has 2 pairs of equal sides and had only 1 line of symmetry. So quadrilateral, in the family of quadrilateral, kite is the only shape which has only 1 line of symmetry, and you can see the figure is already drawn. Second quadrilateral, parallelogram, guys, it has opposite sides parallel, and it has no line of symmetry. Yani you cannot say that this is the line, or the diagonal is a line of symmetry. In the case of rectangle, it was also not a line of symmetry. So in parallelogram, no diagonal can be, because if you try to fold it, this point goes here and this point goes here. No, never. And also this is not a line. The diagonals cannot be lines of symmetries. So parallelogram is a shape, keep it in your mind, has no line of symmetry. But order of rotational symmetry is 2, because if you rotate it 180 degree, it will look like the same, and further 180 degree to complete the rotation, it will repeat itself again. So in 2 times, it will repeat in the rotation. That's why it has rotational order 2, but no line of symmetry. So kite has 1 line of symmetry, and the parallelogram has no line of symmetry, but order of rotation 2, and kite has only 1 order. But does it have a rotational symmetry? No. Next. Now I want to take you guys to the question number 4. In question number 4, the interesting fact is this, that I have parallel lines. So guys, parallel lines, when comes in front of us, we need to use the famous Z property concept. Z property, I have parallel lines, use the Z concept. This angle is equal to this, and this is called alternate pair of angles. Another important property for parallel lines, these two angles are supplementary. So same side angles are always supplementary in parallel lines. Is it clear? And also we remember that this is corresponding angles. So if it will come to us, we will use it, but at the moment I am focusing on Z concept. So parallel lines are here. So maybe I will use the the properties of alternate pair of angles. So I'm going to talk about that. So check it out, guys. Can I make a Z? Look at that. This is the Z. So this is 42. I will write this 140. Second property, which I can use here, in front of me, there is a diameter. So can I join the endpoints of the diameter anywhere on the circumference? Answer is yes, at C. So I got a 90 degrees. So my friends, this is 90, this is 42. I can easily find this angle. So that's not difficult for me. Another important property I can see here, that this arc, if I join here on the circumference and also I join it on the circumference, so this is 42 and this is also 42, angle in the same segment. Another property, I can see there is a cyclic quadrilateral. Why cyclic quadrilateral? Look at the point A, point C, point D, and point E. All of them are on the circumference, and when you join them together, you get a cyclic quadrilateral. So it's a cyclic quadrilateral. If this angle is 42, the opposite angle is 180 minus 42 will give you 138. So this is also the another concept where he brought cyclic quadrilateral inside it. Now we look at the parts. First question is BCA. BCA. Remember I told you we use the Z concept, which is a pair of alternate angles. So if this is 42, that has to be 42. So I found BCA angle easily by using which property? Alternate pair of angles. So specifically in this case, examiner gave you 2 marks. So 1 mark for the correct measurement and 1 mark for writing the reason. So here the student has written the reason, alternate interior angles. So it is better you can mention also interior in between, not only alternate pair of angles. So if you mention alternate pair of angles, examiner will accept it, but it is better to make it more precise because there is alternate exterior angles and alternate interior. So this is alternate interior angles. Next is ACE. So A, C, and E. Can I join them together? Oh, yes, this is 90 degree. The reason is this is diameter. So when the endpoints of the diameters are joined with any point on the circumference, we get a 90 degree. So this is a right angle in a semicircle property. So right angle in a semicircle property. Now I'm going to go with the CFE. So CFE, let me erase everything. CFE, this is C this is F, and this is E. Wow. You remember, if this is 42, angle in the same segment, that has also be 42. So which property? 42, angle in the same segment. CDE. CDE. Where is C? This is C, this is D, and this is E. Remember, we use the property of cyclic quadrilateral. So the opposite to 42 is 180 minus 42, which gives you 138. The reason I will quote here, opposite angles in a cyclic quadrilateral are supplementary. And here you go, opposite angles in a cyclic quadrilateral are supplementary. Now we go to the question number 5. In question number 5, again, before I look into the questions, I try to discover what are the properties I can use here. Done? My friends, he has given you this angle 88. So if I use this arc, and this arc is producing angle at the circumference 88, can I use angle in the same segment property? So this should also be 88. Agreed. This is 88. Now angle at the center, this one, because he is using this, and at the center, you remember, double and half. So if this is 88, then this will be equals to, it will be the double of 88. So 88 times 2 will be 176. I can easily find it. And then 176, I will subtract it from 360 to get my W. The moment you get W, it is double, and I take the half of that, I can easily find V, or I can use cyclic quadrilateral property. You remember? So if I know this is 88, I can find easily V. If I find V, which is, guys, you remember it is half and it is double, so W can be easily found. Now, if I know these two angles, boys, I can find this is 24. So if this is 24, angle in the same segment, if it is 24, the U should also be equals to 24. So everything is discussed. So let's go part by part. First question is, I want to find U. So where is U? This is U. So let's work on this arc. This is making an angle at the circumference, 24. And this is also equals to 24. How did I get it? You remember he already gave it to you. This is 68. And this is 88. I will add them up and subtract them from 180. It will give me 624. So this will also be equals to 24. So angle in the same segment and triangle sum of angles, which is always equal to 180. Two properties I used that helps me to find the value of U. It must have 2 marks. Let's check that, how much marks he has put for it. I think he has put 4 marks. Maybe in U he has put 2 marks because 2 properties were used. 92 he found for V. Let's check how he got V. Yes, guys, I think this is very easy. This is 88. How did I get 88? You remember, this is angle in the same segment again. It gives you 88. So that is also 88. And then cyclic quadrilateral property, I used 88. So this is 180 minus 88. That will give you. Again, which property? So you found this 88 because this was 88 angle in the same segment. Then I focus at cyclic quadrilateral. Opposite to 88 is V. So 180 minus 88 will give you the angle V. W. The W, you can again look, this is your central angle, and this is angle at the circumference. You remember this is always double and this is half. You found V, take the double of that, it will give you. So the double of 92 will give us 184. Question number 6. I'm going to raise this, I'll explain you again. In this property, guys, I have the central angle. This is double and this is half. So this, if he says that this is 3y, that should be 1.5y. So this angle is 1.5y. Also, in cyclic quadrilateral, boys, cyclic quadrilateral, if this angle is given to me, this angle will be supplement to 4y plus 4. So what shall I say about this angle? This angle is equals to 4y plus 4 and subtract it from 180, and it should be equals to 1.5y. Then I solve this equation. How? 180. Let me do the algebra here. So 180 minus 4y plus 4 is equals to 1.5y. Now 180 minus 4y, since there is a minus sign outside, so minus will multiply it with both terms. And then send the minus 4y to the right. So 180 minus 4 is 176 is equals to 1.5y plus 4y. And then 176 is equals to 5.5y. And then 176 divided by 5.5 is equal to y. And finally, it is 32. So important role here in this question, which I found out that sometimes examiner may engage algebra in the properties. So I see that this particular angle was found in two ways: by using the property angle at the circumference is half of the angle at the center, number one, and also by using the cyclic quadrilateral property. So that gives me two angles, and we put them equal to each other to create a linear equation in y, and then we found finally y equals to 32. It's a good question of paper 4. Next, question number 7, boys. Question number 7. It is also on circles. Let us discuss together. Question number 7. I have a tangent. I have a chord. I have a diameter. So this angle is 90 degrees. This is a chord, and this one is tangent. A tangent and the radius, they are making 90 degrees. So it means 4x plus x should be equals to 90 degrees. So 4x plus x is 5x. It is equals to 90 degrees. So x is equals to 90 degrees divided by 5. And we can get x, which is 18 degrees. Now, if x is 18 degrees, if x is 18 degrees now, The twice of 18, this is 36. And then 4x is 72. So you remember chord and the tangent, if this is alternate segment, this is 72. So that also should be 72. And this is also 72 by using angle in the same segment. If this is 72, that has to be 72. You can find this angle by using this 90-degree as well. So there are many ways. If you don't want to use alternate segment theorem, you can find this 90, you can find this 18, this is 72, then you can also find this one as 72. I think all questions were discussed in detail. Uh, GJK, let me check. What is that? GJK, 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 this angle. So as you know, I have found this angle. I have found this angle by using angle sum of triangle. This angle can be easily found. Now we go to the question number 8. Question number 8, we can see two isosceles triangle. Which two triangles isosceles? So look at that. These two sides are equal. So I join them, isosceles. So if this is 42, if this is 42, opposite to the equal side, so it means this is also 42. I found it. Then angle in the same segment, if this is 42, I can get this angle also 42. Now, since these two sides are equal, so this is x and this is x, I can easily find the values of x, which is very simple. Let's do the question number 9. Again, my friends, cyclic quadrilateral property. He gave you this angle 146, which is double. And I'm going to take the half of 146, which is 73. Then cyclic quadrilateral property, 180 minus 73 will give you 107. Question number 10. I can see here the guy gave me tangent. He gave me chord and it is making 27. Okay, did he join anywhere? No, he didn't join. So it means that property cannot be used. But on the other side, if this is the chord, if this is 58, then I'm gonna join the endpoints of the chord anywhere, which is at point R, that is also 58. So this is alternate segment theorem. Done. The guy gave you this is 74 already. So cyclic quadrilateral. This is cyclic quadrilateral. So opposite to 74, this is 106. And if this is 27, I can also write by alternate segment theorem 27. All the rest of the angles are easily found. Question number 11. Now in question number 11, I can see the central angle is given to me 22x. What is the half of 22x? That is 11x. But by using cyclic quadrilateral property 25, so this angle is equals to 180 minus 25x. So put them equals to each other. 180 minus 25x is equals to 11x. And this will help me to find the value of x by sending 25 to the other side. So 180 is equals to 36x, and then 180 divided by 36 will give you the value of x. So that is pretty much easier for you. Now look at question number 12. In question number 12, he says, shade one circle in each diagram so that the figure has one line of symmetry. Obviously, we will shade this square to make one line of symmetry. This and this. This is one line of symmetry, so I'm going to shade this part. Rotational symmetry of order 2, guys. So this is the center when you rotate it. So this square will go to this, and this square will go to this. So I have to shade this square in order to make my rotational symmetry of order 2. Now I have a 3D symmetry in front of us. We have a rectangular based pyramid. So this is a rectangle. You remember a rectangle has how many lines of symmetries? 2 lines of symmetries. So if I draw this, this, and this, so how many planes of symmetries I can draw? Obviously, 2 planes of symmetries can be drawn. If you have a square-based pyramid, then I can have, 4 planes of symmetries. So the planes of symmetries depends upon what is your base. If my base is a rectangle and rectangle has 2 lines of symmetries, believe me, guys, the 3D shape will have same number of planes of symmetries. So as I said, I have 2 lines of symmetries for the rectangle, then 2 planes of symmetries. In question number 13, he says, he gives you the list of 6 shapes, square, rectangle, equilateral triangle, kite, trapezium, and parallelogram. Square, you already know, it has 4 lines of symmetries, 4 order of rotation. Rectangle has 2 lines of symmetries and 2 order of rotation. Equilateral triangle, it's a regular polygon of 3 sides, so it has 3 lines of symmetries and 3 order of rotation. Kite is a trapezium. It has only 1 line of symmetry. The order is 1, but no rotational symmetry. Trapezium is like this. It has 2 parallel sides. Okay. If it is isosceles trapezium, then definitely it has 1 line of symmetry, but he's not talking about isosceles trapezium. He's talking about general trapezium. So it has, I don't know about his line of symmetry or order of rotation. Parallelogram has no line of symmetry, but order of rotation too. So generally speaking, we talked about the symmetries for these 6 shapes. So he said, can you name a rotational symmetry of order 3, that is equilateral triangle, the rotational symmetry of order 2, and exactly 2 lines of symmetry? So can I say, guys, it's a rectangle, 1 line of symmetry only, and that is a kite. Clear. Next, question number 14 we have, and then the guy said a rotational symmetry of order 2. As I said, if this is the shape, this is opposite to it. I shade it. Then this is the shape, opposite to it is this one. You need to shade it. If this is the shape, opposite to it is this one. So I hope you got the idea that I have to shade this circle, a square, and this square to make the rotational symmetry of order 2. Next, I want to shade two squares so that it has one line of symmetries. Guys, it's a square. Be careful. This is the line of symmetry. So this and this, this and this, and this and this. That's why this line of symmetry will work with you. Done. Now we go to the next part, which is like on the grid, draw a quadrilateral, no rotational symmetry, but one line of symmetry, famous kite. In the kite, the adjacent sides are equal, and you just show it has one line of symmetry, but no rotational symmetry. Parallelogram is the shape which has rotational symmetry of order 2, but it has no line of symmetry. Question number 14. Guys, complete the pattern. So I think the pattern has been completed here. So if it is done like this, I have to draw this. If it is this, then I have to draw like this so that it has this line of symmetry. Yep. It's a triangular prism or isosceles triangle here, right angle isosceles triangle. So it goes back. Since it is isosceles, it means I can draw this line, which is the line of symmetry. It can complete the plane of symmetry. So one plane and then one plane in along the length. Any other cross section you can cut from there. So two planes of symmetries you can cut. Number one, the plane of symmetry, this one. And the second one is this. So two planes of symmetries. We have in front of us the cross-sectional face pentagon. So is he talking about a regular pentagon? So regular pentagon has how many lines of symmetries? 5 lines of symmetries, and with the help of these 5 lines of symmetries, you can draw 5 planes of symmetries, because in regular polygons, the number of symmetry, the line of symmetry is same as the number of planes of symmetries, because pentagon has been made as a prism. Because if pentagon is taken back, you can get a prism. So the prism has plane symmetry because it's a 3D shape. So 2D shape, it has 5 lines of symmetries. Now, if this pentagon is made prism, then rather than saying lines of symmetries, now planes of symmetries, but same planes of symmetries and same order of rotation. In 2D, pentagon has 5 order of rotation, but in the 3D, it has axis of rotation. When you rotate it about this axis, so 5 times it will repeat itself. So axis of rotation order is also 5. Now in front of you, we have a cuboid. We know that we can draw 3 planes of symmetries. You can pick the midpoint, 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 midpoint. So this is my first plane, midpoint along the heights, join them. Second plane, midpoint along the widths, join them. You can find the third plane. So there are 3 planes of symmetry you can draw in the rectangular prism or cuboid. We have again a cuboid. How many planes of symmetries? Oh, it's not a cuboid, guys. It's a square-based prism, square-based. And this is a square, and he has taken it back. So how many planes? First of all, how many lines of symmetries in the front face I can draw? 1, 2, 3, and 4, and a 5th one is in the middle. So 5 planes of symmetries you can draw on this 3D shape. Now, how many x's, guys? Look at your space through which the axis is passing. Is it a rectangle or a square? It's a rectangle. So if it is a rectangle, how many orders of rotation of a rectangle? Two. So same is the order of rotation about the axis is 2. Now finally we come to the probability questions, guys. So now we have probability questions. I want to show you here. We have all of them in a landscape form. Let me check how can I fix it. Wait. Now, question number 20, you can look at that, in which he says Calvin chooses pair of trousers and a shirt to wear for college. He chooses gray trousers or black trousers. So in first trial, I have either gray trouser or a black trouser. He chooses a red shirt or a yellow shirt. So shirt is his second selection, maybe red or yellow. Now he has created a tree diagram for you. So if he goes for the gray trouser, 1 over 3, obviously the sum of the branches is always equal to 1. If this is 1 over 3, that has to be 2 over 3 because we know 1 over 3 plus 2 over 3, that has to be equals to 1. So we can easily complete um, this space and this space. Next is the probability he chooses a red shirt. So the red shirt is 4 over 5. Obviously, 4 over 5, when you subtract it from 1, it will give you 1 over 5 for the yellow shirt. So after completing our tree diagram, the first question comes to us is, what is the probability Kelvin chooses gray trouser and a red shirt? So gray trouser, this is the gray trouser and a red shirt. So in probability, when you move along the branches, you have to multiply their probability. So 1 over 3 should be multiplied with 4 over 5. That's why when we multiply this, we get 4 over 15. Next question, what is the probability that Kelvin does not choose either black trouser or a red shirt? This is a tricky question. Let's discuss it. Um, does not choose either black trouser or a red shirt. Does not choose black. If he doesn't choose black, so obviously these options cannot be chosen. Red shirt. So only, and he said like does not choose. So red cannot be chosen. So the only branch which is left to us, that is gray and yellow. So gray is 1 over 3 and yellow is 1 over 5. So 1 over 3 times 1 over 5 will give you 1 over 15. Now we go to the question number 21. Lewis has 3 black pens and 7 red pens in a case. He takes 2 pens from the case at random without replacement. You remember, without replacement tells you that you are not going to put the pen back into the total number of pens as in with replacement, you can put it back. So the number of pens in the second roll will not be affected. But in this case, without replacement case, the number of pens in the second roll will be affected. As you see, total were 10 and now it becomes 9. So if you want to pick first time the black or a red, the probability of black is 3 over 10, then 10 minus 3 is 7 over 10 will be the probability of red. So we found it. Then be careful, it's a without replacement case, so 10 changes to 9 because one pen is short. So from the black also 1 is short, so 2 over 9. So 9 minus 2, 7 over 9. This is also done. And then total 10, now they become 9. So one red is gone, so it became 6. So 9 minus 6 is 3 over 9. If you add all of these probabilities, guys, if you add them, suppose if you add this and this, the answer is 1. If you add this and this, the answer is 1. And so it shows that we are on the right format of probability question. Um, First question is two black pens. So two black is this and this. So you need to move along the branch. 2 over 3, 3 over 10 times 2 over 9 will give you the answer. Next is Lois takes two different colored pens. So different colored pens, let's do this. Different colored pens. We have two cases. First is black and red. And then we have red and black. So what I'm going to do, I will do 3 over 10 times 7 over 9 plus 7 over 10 times 3 over 9, or you can find this probability times with 2 because both are the same things. That's why he multiplied here with 2. So the answer will come to you 7 over 15. Now the next question, in box A, we have two white balls. Box 2 contains four white balls, three black balls, and chooses at random one ball from each box. Find the probability that the ball are both black. For sure, the probability is 0 because in box 1, there is no chance he's gonna get the black ball. So the answer is 0, straightforward. That's why 1 mark it has, because there is no uh, working required, just a little logic use, and we got the answer. Second is find the probability that these balls have different colors. Yes, this is possible. That if, for example, in box 1, I get white, so both are white, so 2 out of 2, 2 over 2. And from here we get, since white is drawn from box 1, now black will be drawn from box 2. So there are 3 blacks out of 7, so 3 over 7. So you can easily simplify and get the answer 3 over 7. From the original contents of box 2, Billy chooses at random two balls without replacement. What is the probability that these balls are both white? Now he's going to choose from box 2. So if he picks at first time, total were 7. There were 4 white balls. Since it is without replacement, now definitely 7 will change to 6. So also white is reduced by 1, so 3 over 6. Multiply them together, you get 12 over 42, or you can write in a simplified form. As the question carries 1 mark, no need to answer in simplified form, but if you do it from the calculator, calculator will provide you simplified answer. Carla chooses one of the box at random with the original box content. She then chooses at random one ball from this box. Now find the probability that the ball is white. So guys, you can see I am actually willing to pick one of the box, and then I will go for a white ball. Suppose she chooses box 1. What is the probability that she chooses box 1? Because there are two boxes, the probability of choosing box 1 is 1 over 2. Then she picks the white ball, so 2 over 2 is the probability. So that is a case number 1. Now, but if she chooses box number 2, the probability of choosing box number 2 is 1 over 2, and the probability of getting the white out of it, it is 4 over 7. So this is the second case. Now, when we have different cases, we need to add them up. If we add them up, and we will get the answer 11 over 14. Again, I will tell you that in box one, if she chooses box one, the probability of choosing the box one is half times getting the white out of it, it is 2 over 2, plus if she picks box 2, the probability of getting box 2 is half, and then later she gets white out of it, the probability was 4 over 7, and then the two cases will be added to get the answer 11 over 14. Question number 23, Sandra has a fair eight-sided spinner. The numbers on the spinners are given to you. When she spins the spinner twice and records each number it lands on, he said like both numbers are 8. You know, guys, first time if she gets 8, the probability is 1 over 8. And if the second time she gets, it is again 1 over 8. 1 over 8 times 1 over 8 will give you 1 over 64. Now, the second case is both numbers are not both 8. So can we go with the complement situation? 1 minus 1 over 64, which is the probability of both 8. If you subtract it from 1, that will tell you that both numbers were not 8. Got it? So this gives us the answer 63 over 64. One number is odd and one number is even. Very simple. If you look at the list of the numbers and check that how many of them are odd, there are three odds out of 8. So 3 over 8 is the probability of getting odd, and 5 over 8 is the probability of even. Times 2 means like if first time he gets odd, then even. Times 2 tells you that even and odd and even, both, in both orders, he gets this answer. So two cases will arise. Rather than adding the two same cases, he just multiplied with 2, and his answer is 30 over 64. So probability of getting odd is 3 over 8, and probability of getting even is 5 over 8. So the first case, odd, and then even. This is the case number 1, plus in the second case, first is even, but then odd. D part was interesting. He said like the sum of the two numbers is at least 13. Guys, you can make a two-way table, which I have explained it to you in the class, because the guy has given you three. Let me make the two-way table here: 3, 4, 4, 4, 5, 5, 6 and 8, and you write here 3, 4, 4, 4, 5, 5, 6 and 8, but it will take a lot of time. Okay, and then you will make a sum table. Total, how many elements here? 1, 2, 3, 4, 5, 6, 7, 8. So 8 here and 8 here. So in other words, I'm going to get 64 outcomes. So out of the 64 outcomes, I can count which are coming in the specified category. But here you can see the student has written possible cases of any, the sum should be at least 13. So you may have 8, 6, 8, 5, 8, 8, 6, 8, and 5, 8. So two-way table can give you the answer directly, which is 7 over 64. Yani, as I said, maybe there are 7 cases out of 64 which has the sum greater than 13. But if a student wants to do this question in case wise, so first if you get 8, 6, 6, 8 times with 2, 8, 5, 5, 8 times with 2, 8, 8, only one case, 6, 8, he got this answer, and 5, 8 is also, because it's a double case, so same probabilities, that's why times with 2. Final answer is 7 over 64. This is again up to you which method or which step you want to follow to get your answers. Sometimes in probability he gives you the probability table and he gives corresponding probabilities. As you remember that the sum of the probabilities is always equals to 1. So you can generate the equation and get the value of x, which is 1 over 8. Next is Ravi spins the spinner twice. What is the probability? 2 or 3? So the probability of 2 is 1 over 4, plus the probability of 3 is 1 over 3. You just add them up and get your final answer. Ravi spin the spinner twice. Find the probability that the number is 2 on both times. So probability of getting 2 is 1 over 4. Again, in the next stage, he's getting 2, so 1 over 4. Alternatively, when we do the experiment, we need to multiply the corresponding probabilities. So first time to 1 over 4, second time to 1 over 4, 1 over 4 times 1 over 4 is 1 over 16. Sum of the numbers is 3. So guys, again, you can create a two-way table, or if you don't want to do the two-way table, so look sensibly that the sum of the numbers is 3. There are only two options. Either I get 1, 2 or 2, 1. So to get the probability of 1, it is 1 over 6, and the getting 2 is 1 over 4, and times with 2 because both will give you the same probabilities. So you got answer 1 over 12. Now, Ravi does this thing 72 times, get the probability of getting 1. Getting 1 is 1 over 6. And since he does this and he expects this in 72 times, so multiply this probability with 72, it gives you 12. And 12 is the number shows you that 12 times you will have the number 1 expects in 72 spinnings. Question number 25, it is on graph of functions. In the class, I told you he will give you the equation. You may open the calculator, and in the calculator, we have a table function. You go over there and use this table function, and just write x squared plus x minus 6, x squared plus x minus 6, enter. From where you want to start, can you check that? I want to start from minus 3. I want to start from minus 3. I want to end at 3. What is the step I have chosen from minus 3 to minus 1, minus 2 to minus 1? So each time he is adding 1. So step of 1. Now, guys, your inputs and outputs, the values of y's are also given here. You can check that all of the values are matching with the calculated answers. If a student doesn't want to use this function, he can use also the manual way, which is basically I'm going to write bracket open close squared plus bracket open close minus 6. And then in the brackets, I'm going to write one by one the numbers which are my inputs. So I'm going to write here -3 again. So check that, guys. I got the answers for my y's. Now I have this point, this point, this point, this point, this point, this point, and this point. How many points? A, B, C, D, E, F, and G. You have to plot all these points here. So this is the A point, this is the B point, this is the C point, and D point, E point, and you plot all the points and join them smoothly. You get the curve. After that, examiner asks you, what is the solution of this equation? But graphical solution. So graphical solution is the graph has been already drawn. On the other side, y is equals to -2. So just draw y is equals to -2, the horizontal line, and check that where the curve and the line are intersecting. They're intersecting at this point on the x-axis. So my solutions are 1.6 and -2.5. You can check your answers from the calculator. It's easy. I can use the equation solver technique, x squared plus x -6. I can write the equal sign and -2. I want to solve it, press shift solve. Shift solve. This is not the solution. This is the guess, initial guess by the calculator. I press equal sign. Now calculator calculated for me 1.56. And did you see I got my answer 1.6? So graphical solution is very close to the accurate solution. Then again press equal sign and put your guess closer to -2.5. So I put my guess -2 and then enter. So imagine calculator will give you the exact answer, and you can see how much our answer is closer to the accurate answer. So graphical solution is -2.5, but the calculator gave me exact answer, which is -2.56. So it shows the authenticity of your graphical solution. Next is examiner gave you Another equation, quadratic function. He gave you the list of x values from -4 to 3. So if you want to use calculator, your start is -4, your end is 3, and your step is 1. So automatically you will get all these values. So I got how many points? A, B, C, D, E, F, G, and H. So all these points, you will plot them here. You will plot them here, and that helps you to draw the graph smoothly, and then a parabola will be formed because all quadratic functions are parabolas. Next question is, he's asking, what is the line of symmetry? Guys, you can see that the line which cuts the parabola in two equal halves, that is the line of symmetry. So obviously this is x is equals to 0.5 minus 0.5 is the line of symmetry. Then he's saying use the graph to solve this equation. This is matching with the graph which has been plotted. What is written on the other side? 0. So y is equal to 0 means x-axis. I want to check that where the line is cutting the x-axis. It is cutting the x-axis at these 2 points. So these are my 2 solutions. Again, if you want to use the equation solver, I can write x squared plus x minus 5 equal to 0 and press shift solve. Calculator will give you initial guess. You need to put the equal sign. So my answer is minus 2.79 accurate, which is very, very close to minus 2.85. It means examiner will accept my answer. Now I want to change my guess and put it closer to 1.8. Suppose I press the equal sign and write my guess as 1.7, which is close. And then automatically calculator will modify its answer and bring it closer to my graphical solution. So 1.79 is the exact solution, and I got 1.8, which is close. So it means my answer is accurate. After taking 2 quadratic functions, the last question of the review pack, it has a reciprocal function. And you know the reciprocal function, they are drawn like this. This is the rough sketch of reciprocal functions. Again, use the calculator table function. You start it as -6 and you end it as 6. There is a gap between these two, so it means the curve has 2 parts. Don't join them. Okay. So -6 to 6 with a step of 1, you can do that, or step of 2. It's up to you, but you have to fill the empty spaces provided in the table. Then you plot the points. As I said, don't join them. Don't join them because this tells you that there is a gap between them. Now, after drawing this, he said, can you draw the line y is equal to 5? Very famous. Y is equal to 5 is the horizontal line. So I draw y is equal to 5. Where they are cutting, guys, because in the next y is equal to 5, and 12 over x, he put them equal to each other. When you solve it graphically, you check that where the y is equal to 5 line and the graph are intersecting, that is 2.4. And if you want to verify your answer from the calculator, you can do that. You can write here 12 over x equal sign. I'm going to write it. And then 5 shift solve. Can you check? I got 2.4, which is very accurate, matching with my graphical solution. So that's all, guys. I hope this whole discussion was helpful for you and you understand the concept very well.